Okay, so this question here. This is this question here that came up was a really, really good question, because if you remember, I told you some time ago that there's always one question in the exam that has a graph in it. So that's this one here, okay? So you don't need to know right now. There's some circuit here, and there's a voltmeter and there's an ammeter, okay? And they give you the results here. So the first thing to do is put this in a graph. So I'll just put the numbers down so you can write them down. I can't remember, if I want the V on the y-axis and the I here, which do I type in first?
X first.
The X goes in first, does it? So then the Y. So IV like this, isn't it? Okay. So 8.21, 7.09, 4.88, 3.71, 2.52, 1.70. And then the V, 0.33, 0.710, 1.46, 1.86, 2.26, 2.43, 2.54. Ah, what the heck? It's like I lost some numbers here. 8.21, 7.09, 4.88, 3.71, 2.52, oh, 1 fell off, 2.03, 1.7. Okay. 0.33, 0.71, 1.46, 1.86. What?
You didn't see that.
Just check it.
Okay. Now, for 8 marks, you have to draw this and then calculate the M and the C. Okay? M and C. So I'll draw it just using Excel to save time here. Insert chart. So I should highlight this first. Insert chart. Okay, so we need scatter like this. Next. Okay, and to make sure you get full marks, you have to put the title in. So this graph would be voltage versus current, and then the x-axis we called was the current I, which is in amps, and then the vertical axis is the V. Now also, just so you know, okay, I like to use brackets, but in the exam they like to do it like this, use a / to show you the units. I don't like this, I don't think it looks nice, but it's what they want to do in the exam sometimes. You don't lose any marks, but just so you've seen it, I'll write it this way. So this means I in amps and volts, voltage in volts. There we go. So you get that, and then I'll put in my line. Insert trend line. Yeah. And then we move this over. Okay. So 8 marks for drawing this and getting the M and the C. You get the C is here on the graph. It's where it crosses the y-axis. And the M, how do you calculate the M? You draw in the big triangle, or you take the 2 points.
So should we draw everything and just
Yes, yeah. So can you just note down the equation, please, and just draw a rough sketch of that graph. I'll make it a bit smaller so you can see the data as well. No, it's good temperature now. At the start you complained it was hot. Now you're complaining it's cold.
My throat and
Yes. Everything is terrible.
Yeah.
Yes. What's wrong? You want some coffee?
No, I have it, but it's cold.
Did you draw that?
I took out the V equals MI.
You got the equation? Good, okay.
So it's a good question,
You must, in my opinion, you must always do the question that has the graph in it. Because as you can see, it's 8 marks, 8% for drawing the graph. Can I have the formula book for the moment? Where is it now?
Should I find the functions?
Now, yeah, well, it's in the formula book. So, shh. Now, this diagram here, and I won't draw it, but can you all see it here? Okay, can you see that? So let me just explain briefly what it is. You have a power supply, you have an ammeter for measuring current, you have a voltmeter for measuring voltage, and you have a resistor here. But what's really, really important is that this resistor here, you can change it. Now, we did this a while ago. There's a special circuit that has a couple of parts to it. Firstly, a battery, okay, and then an ammeter, and then a voltmeter, and then a resistor that you can change. You can put these together, and there's a formula you can find, and one of the Section A questions we did a while ago, I think, was to find this formula. But even if you don't remember the formula, which is okay, the formula is listed in the formula book. In the formula book, there are 3 formulas under electrical circuits. The first one is resistors in series, the second one is resistors in parallel, and then the last one is this formula, V equals E minus I or. Now this is in the formula book. Focus, please. What are you doing? What are you up to? What did he do?
Nothing.
Please.
Where's Brandon?
Printer room.
His position very dangerous.
You know what? I think you're right. Joseph,
Yeah.
move over there so I can see you. I don't trust you there. Get moving. Come on. This way there'll be no misunderstandings. Now, this formula here is in the formula book. And when do you use this formula? This formula is when you have a circuit with 2 resistors. The first one is the small resistor that's built into the battery, and the second resistor is one that you change. And as you change the big resistor, you notice that the V here changes and the I here changes. Yes? No, come on, please, focus. Now, I'll say this again because it's really important, so can we please listen?
Listening.
We have gotten 8 marks for drawing the graph. And then there is another 6 marks. 6 marks for getting the E. So now that we have our equation, we can compare it. What was the equation I just gave you? V equals, or Y equals, yeah, give me the C part, please.
3.11.
Yeah, minus,
Wait, this is C.
did you write the equation down? Avenue, you said you wrote the equation down. Please give me the C in the equation.
I don't remember. I wrote V equals.
Avenue, you're going to get into so much trouble with me and Lorraine now.
I'm serious.
Get focused, just stop now.
I wrote the equation. You're asking for C. I'm giving you the equation.
Yeah, but give me the C part of the equation.
3.11
Thank you. And now minus,
minus
yeah,
M.
yes,
Oh,
0.3396.
I couldn't hear that. I couldn't be so.
X.
Alright, so sorry.
which is I here. So if you look here, this one here, you got this from your graph, but you realize that if you compare the two, this here is the E, and then this number here, that's the small r. So you get 6 marks now for saying E equals 3.11. So that is 16 marks, okay? 16 marks for writing this and doing the graph. 16 marks.
Whoa!
Yes.
Where did you get E?
We got it because this is given in the formula book, and this is what I found on my graph, and we just, compare them. So this must be the E, and this must be the R, because you see there's the I there. No? Oh, E is where it crosses the y-axis. It's the C. It would be this number here.
The
Yeah?
question is, how would you get it from the drawings?
Oh, you read it. You do this on graph paper, and you see where it crosses the y-axis. So it'll be slightly different for different people, which is okay. So when you draw it, you would say the C, it looks like it's about 2.75, What did we get? Well, actually, mine's not very clear here. I don't think this is too... Yeah, if I look at this graph, it seems to be about 2.75, but if you actually look at the formula here, it's 3.11. But you got to remember, this is an Excel formula. What you would actually do in the exam is you would read it from your graph always, okay? So don't worry that it doesn't seem to match up. I'm not sure why it's not quite matching up. But anyways, 2.75, if you read it from the graph, 3.11. Okay? But that's, a lot of marks for not doing much. Okay? Now the last part here, calculate the power when the voltage is 0.33. Now if I go back here, he says when the voltage is 0.33, what's the power? Well, again, that's also easy, because what's the formula for power? Yeah, it will equal this number, multiply this number, so the power is 2.7. So now that is 18 marks in total, 17 marks in total. So now for the final tree, so if we look at the diagram here, the question is, why would having 2 batteries in parallel be better? 20. So why would 2 batteries in parallel, why is that better than 2 batteries in series? Any ideas?
Less internal resistance.
Yeah, you think about it. Your batteries have a small little resistor, don't they? So in this diagram, what's the total resistance? It'd be 1 over R plus 1 over R. The total here is 2 over R. Yeah, which is 1 over the total. So then the total here will be small r over 2. But then if, that's if they're in parallel, of course, yeah. But if I have them back to back, it would be r, what would the total be? R plus r, which is 2r. So you have a choice. If you put them back to back, the total resistance would be 2r. But if you put them in parallel, the total resistance would be a half r. That's 4 times different. So you really reduce the resistance a lot if you put your batteries in parallel instead of in series. So the answer is to reduce total resistance. So if that question came up in the exam, I think that'd be great. Something like this would be a really, really, really good question. This would be the electricity question in section B. Oh, that was number 4 in the workbook. I think this is probably the best electricity question I've ever seen in the exam. Because not only is it electricity, but it's also the graph question too, which is always good, okay?
I'm mixed up. I'm mixed. I mean,
Yeah.
long questions. How many? There's 6.
Roughly about 6, 7 or 8, depending how big they are.
And we must
So
About
section
8.
B.
Section B, you choose 3 long
You
questions
choose
from 6.
3 from 6,
Yeah.
and each one is how many?
20.
20.
So the exam is 40, 20, 20, 20.
40A.
40
For A.
and B 60.
60, yeah. 3 20s. Yes?
Also, section A is
40. Like in maths.
But we must do it all.
Yes, yes.
20.
How much can it be? The 8.
A is usually about 8.
So it's just yeah.
So there's
Usually.
5.
But it's sometimes, some questions might be 6 or 7, and then maybe
Yeah,
some will
that's
be 3. It changes a lot. About 8 questions.
I like question section A.
Yeah, they're okay. Now, I'm going to do another electricity question now. So, next one now, number 5.
Is that the third one we did now?
Yes.
Second one?
That's 4th one. Electricity one done.